A particle P moves in a straight line such that its displacement x meters from a fixed point O at time t is given by x is equal to 9t minus 3t squared. We want to find the time when the velocity is 0. X is equal to 9t minus 3t squared. Velocity is given by dx dt, and this is 9 minus 6t. If velocity is 0, then 9 minus 6t is equal to 0, which means that 6t is equal to 9, so t is 9 divided by 6, which is 1.5. We now want to find the distance travelled in the first 4 seconds. Let's draw a diagram to help us with this. We'll assume the particle is here when t equals 0. We know the velocity is 9 minus 6t. Consider t equals 1. Velocity will be equal to 9 take 6, which is 3. This is a positive velocity, and we'll take this to the right. So the particle moves to the right to begin with, but we know the velocity is 0 when t is equal to 1.5. The particle will then move to the left. If we look at this expression for v, we can see if t is more than 1.5, v will be negative, and this must represent movement to the left, if a positive value for v means movement to the right. Let's suppose it's here at t equals 4. If we call this distance d1 and this one d2, the total distance moved will be d1 plus d2. Let's consider d1 to begin with. We have an expression for displacement, and d1 is just going to be 9 times 1.5. Take away 3 times 1.5 squared. This calculates to give us 6.75 meters. Now to consider d2. When t equals 4, x is going to be 9 times 4. Take away 3 times 4 squared, which is 36. Take away 48, which is minus 12. This means that the particle is 12 meters to the left of the start point. In other words, this distance is 12. We know that this distance is 6.75. Therefore, d2 is going to be 12 plus 6.75, which is 18.75 meters. The total distance travelled by the particle is 18.75 plus 6.75, which is 25.5 meters.